Hello and welcome to the 8th video in this series making simple Flappy Robin for Android using Cocos2dx version 3. Sorry there's been a bit of a delay from the previous videos. I'm really busy with work at the moment. It's very difficult to find the time to get to do these videos, but here goes with this one. I'm just going to quickly run the application to explain what I want to do. So we've got the app here with the robin jumping up and down. And what we want to do in this video then is we're going to add a class. I'm going to call this class Cloud. And basically what this class is going to do is going to represent the various graphical objects that scroll by to give the impression that the robin is flying. Now I've already added into the resources section. I'll just click on the smallest version, Cloud here. Then I've added in, well, what's supposed to be a mountain, but I think I said in the version 2, the series covering version 2 of Cocos2dx, it looks more like a pudding. And also a tree in there. And we want to add these on then to just scroll across the screen. And if we think about what we need with our class, basically we'll create an array, or well, you would have done in Cocos2dx version 2, but now use what's called a vector class from Cocos2d. We'll subclass Sprite, we'll subclass Sprite. And what we need basically to do is add these sprites to our vector. When the game starts, when you click on the robin there, we want them to scroll, and when the robin dies, we want them to stop scrolling. And when they scroll, they're continuous scrolling. So the point is when they go off the left-hand side of the screen, as soon as they're off, we need them to go back to the right-hand side of the screen, off screen, and scroll back on. So what we'll need is when they start, get started, when we click on the robin, they could be anywhere on the screen. So we need some way of saying, okay, move to a destination, and that destination we need to make sure that destination is far enough off the left-hand side of the screen that they disappear. And then obviously when it hits its destination, it needs to be reset to the right-hand side of the screen, just off the screen, and started off again. So it gives the effect of clouds and trees and mountains continuously coming and the robin is flying. Okay, so a complicated explanation, but the implementation is not too complicated, thank goodness. So we're going to add a new class, C++ class. You've seen all this before. I'm going to call it C and Cloud, like so. And we can get into actually defining our class. What I'm going to do is be really lazy here actually and just copy the definition from the robin in here and rub it over here, and then just change some of the information. So we can call this C Cloud, oops, with a small l. Just saves us a little bit of, a little bit of time. Create with file name. And now what we do need to do though is change some of the functions obviously in here, because they're going to be completely different. We want the constructor like this, and I'll actually take these off as well because we don't need it. So to think about what we're going to need then, we're going to need a function to start. We're going to need a function to stop. And we're also going to need a function to set speed and width. And this is you'll see how this works, to set the width of the screen. So we'll take in there a const float speed and a constant float width. And from the width of the screen, and we can then obviously work out where we need to start, and we'll actually use the width of the sprite itself in here to initialize a private variable to make sure we have an offset that's off the screen. In terms of private stuff, then we need a function for each destination, so we know that when it's gone off the screen it needs to be set back to the right hand side of the screen, and then some private variables. So we have our speed, we have our screen width, and we have our pixels per second, which you'll be familiar with. Oh no, you won't be familiar with from the robin because it stands still. And we have our X offset, which you'll see how we use shortly. So that's the definition then of the class. I'm just going to copy these function definitions then here and just drop into here, and also take the reach destination and drop this in and add in our good old brackets as well. Okay, good. So that's everything set up apart from this last one here. So let's deal then first of all with the sprite creation. Of course we can take this from the Robin because we've already got this. I'll just drop all this inside CCloud like so, and obviously it's no longer we no longer need the static here, but what we do need is the prefix on these, otherwise things will not look very good. So we've got create with file name. I'll just drop this in front of the start, stop, set speed and width, and reach destination. Okay, so we have auto sprite equals new C Robin, everything gets initialized, and we're all okay. So for the start then, in fact no, let's not deal with the start. Let's first of all go to the stop because it's the easiest one. We can say this and stop all actions, because what we're going to do is to move the sprite or to move a sprite, you set what are called actions, and actions are things that you can that are done, say, to the sprite or just done inside the class. So you can make an action to call a function, make an action to move or rotate a sprite, and then you can run these in sequence, which you'll see shortly. So what we're going to do is make an action to move the sprite, which is essentially moving it from where it is with a certain speed off the left-hand side of the screen, and when it's done that, we'll have another action that says when that's complete, call this reach destination, which will set it off to the right-hand side of the screen and then tell it to start again. So inside the set speed and width, we want to set our speed equal to obviously the speed. We want to set our screen width equal to the width. And then our pixels per second is going to be equal to our speed. It might seem a little bit convoluted with me doing it in this way. The reason is these are both essentially the same thing. This is me copying the code from the version 2 version, and I'm just realizing I don't actually need. In fact, what we'll do is we'll just take out pixels per second. This is when I realized that I'd made too many variables and I don't actually need this. So I'll take this out, go back into cloud. Sorry about that. So we need the speed, the screen width like this. And then the last one is the X offset. And this will be equal then to this and get bounding box dot size dot width. And what that basically is going to be is when the cloud scrolls across the screen to the left hand side, it'll keep going until it's its own width off the left hand side of the screen, which gives it the impression that it's disappeared. And when it's reset to the right hand side of the screen, it'll be reset to the pixel at the right hand side of the screen plus its width, again so that it starts from off the right hand side of the screen. Look a bit silly if it started whilst sitting just on the screen slightly from the right hand side. So if we think about it moving then across the screen, I'm deliberately leaving start until last. Once it's reached its destination off the left hand side of the screen, it needs to be reset to the right hand side. So we just say this and set position X, and then it's just our X offset plus the screen width. So this sets it up back to the right hand side, and then we just start it moving again. So last but not least, now we just need to fill up this start. So the first thing we'll do is we'll stop any actions that are already running. They shouldn't be, but just as a precaution we'll stop any actions. And now what we need to do is make sure that the speed is consistent. So we need to know what distance we're actually moving across the screen. So we'll say float distance to travel is equal to our current X, which I haven't declared. So I'll make this easy and say current X is equal to this and get position X. So the distance we're going to travel is our current X, and then minus, and then the minus of our X offset. Okay, I could type plus there, but I find it easier to read this way. In fact, no, let's put a plus in there. That looks rather silly using a minus minus. So basically we're saying if we've got 400, if we're at X value of 400, we've got 400 pixels to travel until we hit the left, and then let's offset our X by our width so that we're definitely off the left hand side of the screen. Remember that the position we're basing on is actually in the middle of the sprite, so it will guarantee that we're off the left hand side of the screen. So the time to travel then will be then our distance divided by our speed. And now that we've done that, we can set our destination. So we can say our vec2 and destination point then is equal to vec2, and then it's minus x offset will be the x, obviously, off the left hand side of the screen, and we keep the same position y that we have all the time. They always stay on the same level. And I'm looking at this and wondering why it's not liking what I've just done. Because I haven't included the namespace of Cocos2d. So using and namespace cc. Okay, I'm just going to build this, let the index rebuild, because I get worried, as you know, when things start breaking there. Okay, good, that's okay now. So we have the time that we're going to take to scroll, and we have the destination we want to reach, which means now we can set up our actions. So the first one is a move to. We'll call it action move. And this is equal to move to, and then there's a create you can use here. So the duration we have, the time, and the destination we also have. So this says move over this time, to this destination. But we then want to call a function. So we'll use call func, and we'll call this action move done. And this is where we want to say, once that's done, we want to call our reach destination function. So the way we do this then is just to say equals call func and create, and then it's cc callback 0, and then the selector is cloud reach destination, and the target, of course, is this. So that's now our action to say call reach destination. And incidentally, I pointed out in a previous video that you can go into the Cocos2dx CPP tests, which I've just got up here on the directory browser here in this classes. And actually, I wasn't familiar before going into this with how much the actions were different to the Cocos2dx version 2. So I simply went into the actions test and had a look in this actions test class here. And in there, I did a quick search for call func and saw an example of how you set up and run this. So it's really, really good and easy reference to use this CPP tests, which remember is inside the test folder inside Cocos2dx version 3. Okay, I digress as usual. So now we've got that, we just need to run these actions in sequence. So you just call run action, and then there's a sequence class, and then you create this sequence. And then, so we want our action move. It's important always to have the null at the end, our action move done, and then the null, like so. And that will then run this move, and when the move is finished, going off the left-hand side of the screen, it'll call this action here, which will call reach destination, which will set it off to the right-hand side of the screen, call start, which runs the whole thing. So whilst they're not stopped, so all actions have been stopped, you have the effect of continuous scrolling. Okay, so that's enough of that then. Let's go into hello world scene.h, and now we need to start adding our classes in. So, or our clouds, sorry, in. And we're going to use, rather than CC array, there's now a new class in version 3 of Cocos2dx called vector, so which simulates the vector class in the standard library, but I think it has memory management in there as well, and retains your objects for you, because if you just add them to a normal vector, you can't then and then add it as a child to the layer, things can end up moved around, and you end up with pointers to not what you think are the objects you're actually wanting to point to. I won't go into that, but try it using a standard library vector and you'll see that things go wrong. So I just want to pre-declare our cCloud class. I think I can do it this way. I'm just going to double check. So I want to say in here then Cocos2d vector, and then I want cCloud and a pointer with a small l, and then just clouds. And I'm just going to build this and see if it lets me do it, because I had some problems earlier when I was preparing this video. And in fact, I need to actually include the class at the top here. So let's just do that and take away this definition. Is it called cloud.h or cCloud? cCloud. Okay, and I'll just build again. Okay, it seems to have some problems when it's compiling, when it doesn't know exactly what the class is, to know that this inherits from, I think it's got to inherit from object, although I'm not sure now. I can't remember. It's got to be a subclass of something, or node or object. I can't remember anyway. The point is, it already does because its subclass is C Sprite, but it basically means you can't predefine the class in this way and then include the file in the code file. Okay, good. So, long-winded explanation as usual. And let's add some functions here as well before we go into the actual implementation to add them in. The first thing we want then is a function to add a cloud, and remember when I'm saying cloud here I'm including the trees and the mountains. So we want const float and the speed, and then we want a const Cocos2d vec2 and the position that we want the cloud to be in, const float scale, const and the z index, and last but not least the file name, which isn't const because of course the create with file name doesn't have a const as an argument there. So that's our function to add in a cloud. Then we have void start clouds, void stop clouds, and last but not least the most important one, void create clouds. Okay then, so that's our functions then created. Let's then take these and we'll drop them into the bottom of the hello world scene.cpp, right down the bottom here, below on touch began. Okay, that's those in. So we'll start with the simple stuff then, and that will be to look at actually starting and stopping the clouds. So to start and stop the clouds, to start them we simply need to iterate through our array. So we can say for auto cloud in this and clouds, oops, should be an underscore, and I haven't prefixed with hello world, have I? As I always forget. Okay, in this clouds, and then we simply need to say cloud and start. It's making me wonder why this hasn't worked. Did I forget the underscore? No, I didn't. That's a const int z index, sorry, I'm back into here, and that's a const int z index. I'm just going to build now. Okay, the build succeeded, everything's okay. I'm a bit bothered again because the indexing's not working yet again, although I can see it's processing at the top. So that then starts our clouds. To stop our clouds then we simply need to call, obviously, stop here like so. And the create clouds here we'll do in a minute because we need to add something into the constants. But let's go up to this add cloud here, if the computer doesn't crash on me. And indeed Xcode has crashed. Who says Macs don't crash? My goodness. I'll just try and open again. Okay, we're back. It's a bit of a mega crash. Hopefully everything's okay. So for the adding cloud then, the first thing we want is our visible size. So I'm just going to go up and grab that from here and drop that in like so. And now what we need then is we need to create a cloud. So we say cCloud equals cloud, and it's cCloud, and there's the create with file name, and it's the file name that we've supplied here. Then we want to say cloud set speed and width, and that's then with the speed and the visible size dot width. Why is it not finding it? Because I've got an extra comma in. I'm a little bit rusty with this, I can tell. And then we want cloud set position. And we want just the normal set position. And then we want cloud and set scale. And the reason we've got a set scale on here is because we want to scale them to give the impression of some distance. So the slower clouds will be smaller and the faster ones bigger, so everything looks a little bit 3D. And last but not least, we can finally add this as a child. And we add the cloud, and the cloud is added with the Z index. And then we'll take our clouds vector and we can call a pushback, and that adds the cloud into our Cocos2d vector. Good. So one more function to do then, and that's the creating of the clouds. Oh, in fact, I didn't realize that the crash didn't have the stop clouds in, so there should be a stop and cloud in here, and I'll save, so if we get another crash that doesn't go. So the last thing we need here is the create clouds. To do that, we need to add some constants. So we're going to add some Z indexes in. So I'm going to say Z index cloud, Z index tree, and Z index mountain, because these are things obviously that we'll need. So the mountain is 30, the tree is 50. I'm just using the version 2 program off screen here just to get these versions out. And actually we need a Z index for a cloud fast, so a fast cloud, it's 20, and then we'll have a Z index for a cloud slow, which then can be set to 10. What we now need is the scaling, so we'll define k cloud scale, and then for the slow, and that will be in 0.4. And we also have to multiply, of course, by get scale y, because the y scaling is what we're using. Then we've got the cloud scale fast. Oh my goodness. And I've set that to 0.85 for now. Obviously doing this way makes things very easy to change. Then we want the mount scale, which for now is 0.8, and then last but not least we want the tree scale, which at the moment is 1.0, so the original image size. So that sets the scales up, and last but not least we now need the speeds. So I'm just going to copy and paste that here, so cloud, and I'm going to replace scale with speed. Speed fast, and mount speed, and tree speed. Okay, so the slow will be 13.0 times scale y, and then this will have to be multiplied by the get scale factor as well, as they all will be. So I'll just drop this in here. Then we've got 53.0 here. These values again you can change to your taste, obviously. 30.0 and 70.0. Good, bit of a ball ache to do all that, but it's all in, and now at last we can go into the creating the clouds. And you'll be glad to know that I'm going to show you one line of this and then do the rest myself, because it's extremely repetitive. The first thing we need to do is create our vector. So we'll say that our clouds is equal to vector, and then it's cloud, and we can specify capacity to start with, and I'm going to say 30. It should never go over 30. 30 is actually more than we need. It doesn't really matter though, because it's not very many as it is. The device is more than capable of dealing with those. And then exactly the same as we had in the previous series for version 2, we've got the file name, and now we'll say get file name, and then we use our file name array, length 32. We'll start with a cloud, and the extension is a .png. And now I'm going to show a line to add one cloud, and then I'll do the rest and cut the video so it's not totally boring. So basically we're saying add cloud, and the speed we want then is k cloud speed slow. The position then, we want to scale a position, and this one is 700 by 610, and then we want k cloud scale slow, z index k, z index cloud slow, and last but not least the file name. And that will have the effect of adding one cloud. And why doesn't it like this constant here? I'll just go back to constants and have a look. Whoops. I've got a multiplication in here, which obviously is completely wrong. Sorry about that, I didn't realise. In fact, I've somehow got a multiplication in front of all of these. What a mess. Apologies for that. I'm a little bit ring rusty. Okay, back into Hello World scene. Okay, good, that's working now. Okay, so I'm going to add in the rest of these lines of code and then I'll bring the video back. Okay, the video's back. Also, I noticed I deleted the T off the fast here when I was taking out those multiplication symbols in the constants. I'm really sorry about that. I'm a little bit rusty, maybe a bit tired today. So this has been a bit of a mess, but never mind. So I've got all of these lines of code in now. You can just download and copy these. It's basically adding a couple of mountains, 3 trees, 3 fast clouds, and now we've got a couple of slow clouds. And now we've got those, what we need to do is we need to call our create clouds, which we'll call just after the game over here, like so. Telesense, the indexing is not working very well at all today. Everything is staying black for too long. And now we need to set the starting and stopping of the animations. So obviously when we start the game here, we'll start the clouds off. And then when the robin dies, which is here, then we can call our stop clouds, like so. And that should be enough. So finally, I can press run after much too much time. And you can see here now we've got the clouds and the mountains, and now you can see when I click on the robin and get him running, it now gives us the distinct impression that there's some depth to the scene and that the robin is actually flying. So all looks well and okay, and when he dies everything stops, and then we can click to get everything to start again. Okay then, so that was a really long-winded video and lasted much longer than I thought it would, and indeed should have done. My apologies for that. I'm a little bit rusty, and again the videos at the moment are a bit difficult because I've got a lot on at work. I try to get them out as often as I can. But anyway, thanks for watching, taking the time. Hope it helps you a little bit, and see you in the next one.